This video is one in a series which demonstrates a feature of quantum scalar libraries called ActiveVault. ActiveVault is an in-library vault that can be used to help protect your data in case of a ransomware attack. This video is specifically geared to ActiveVault in a Veeam environment. I'll demonstrate how to configure Veeam to take advantage of ActiveVault and how easy it can be to recover from a ransomware attack. On the Quantum website, there's a video called Scalar ActiveVault Unique Secure In-Library Vaulting for Ransomware Protection. For more in-depth information on ActiveVault's features and benefits, you should watch that video as well. This video focuses on ransomware protection and recovery from an attack in a Veeam environment. But first, let's look at the environment I have set up. I have a scalar library with multiple partitions. I've made one partition available for Veeam, and the other partition is a special partition I'm using for ActiveVault. Let's look at these partitions in the library user interface. This is a view of the library user interface, and we have several partitions. The partitions we'll be working with for this demonstration is the Veeam backup repository, which is indicated by the purple designation, and the ActiveVault partition, which is indicated by this olive color. Notice the Veeam partition. It has some number of tape slots and 3 tape drives. The black lines indicate there's a tape in that tape slot, and in this partition there's 6 tapes. Notice the ActiveVault partition. It has some number of tape slots, but it has no tapes in there at the moment, and there are no tape drives associated with this partition. Let's go back to the presentation. So we have the library partitions. Let's add Veeam to the picture. This is a fairly typical Veeam environment, a local high-speed repository for the primary backup copy, and tape for secondary copies or long-term storage. Notice Veeam has access to its assigned library partition for backups, but it does not have access to the ActiveVault partition, and you'll see why this is important shortly. And finally, this environment contains some clients which we can back up. Now let's take a look at the workflow I'll be demonstrating. When Veeam makes a backup, that backup image is essentially a file that resides in a primary repository, usually some type of high-speed direct attached storage. And you can tell Veeam to make a copy of that backup image on tape. And finally, for ultimate protection, Veeam can export that tape for safe storage. And this is where ActiveVault comes in. When a tape gets exported, it doesn't actually leave the library. The exported tape is redirected to an ActiveVault partition. From a Veeam perspective, that tape is in a vault somewhere in a mountain, but it's not. It's still in the library and available for rapid recovery. It's just in a vault partition, which Veeam does not have access to, and therefore neither does an attacker. Now let's see how we set this up in Veeam. I have a Veeam environment, and in my Veeam environment I have a couple of backup repositories. I have the default backup repository, which is created automatically by Veeam, but I've also created one specifically for this demonstration, and I'm calling that backup repository Veeam Local Repository. This is the primary direct attached storage. It happens to be using the F drive on this host. Now let's look at our tape. We have a media pool that contains some tape. In this case, it contains 6 tapes. Those are the 6 tapes we saw from the library user interface. So let's create some jobs and see how this works. First, we need to create a tape job. And what we're going to be protecting with tape are backups. We'll give this a name. We'll call it Copy to Veeam Safety. We'll accept some defaults until we get to the options. And what we want to do is tell Veeam to export current media sets upon job completion. What that means is, whenever this job runs, when it's done, whatever tapes were used for this job will be exported from the library. And you give it a schedule. For this demonstration, I'm going to tell it to run this job every time a new backup file appears. And we'll just complete that wizard and indicate we want to enable the job immediately. Now let's create a backup job. What we want to back up is a virtual machine, and we'll just leave the name the default backup job 1. We need to select which virtual machines we want to back up. I'll just select one from the top of the list. We need to define which repository this backup should reside in, and so we selected the Veeam local repository. And for this demonstration, I'm going to drop the retention to 1 restore point. And here's another important setting. Configure secondary destination for this job. So we need to enable that so we can make a secondary copy on tape. And now it's asking which backup jobs should we run to make the secondary copy. So let's just select the one we created, copy to Veeam safety. And we'll go through and take the defaults, and we're going to go ahead and say run this job immediately. So Veeam starts the backup job, and this could take a while, so I'm going to forward fast through this section. So this job finished, and since we told our copy to tape job to run immediately after new backups arrived, it fired up another job, which will make a copy of that backup on tape. Again, we'll just let this job run. So this job finished, and notice a couple things. It created the backup, and when it was done, it automatically exported the media. Let's see what that looks like. Let's go back to our tape infrastructure, and we can see we have a tape with an ID that ends in 8L8, and it is offline. So the important thing here is you really can't do anything with it. You can't erase it. You can't access it, so the data is safe. Let's see what it looks like from the library user interface. Okay, now when we look at our partition, in the Veeam backup repository, in purple, we see only 5 tapes. But in the active vault partition, with the olive color, we see it now has 1 tape in there with the ID that ends in 8L8. So that tape was successfully moved to the active vault partition. Let's go back to our presentation. Now let's go through an example where we have a ransomware attack and how we can recover from that. Currently, our Veeam environment looks like this. We have a primary copy of the backup image in a local repository and a backup copy in the active vault partition. Now let's say your Veeam environment was compromised. An attacker got in and encrypted or stole or somehow made your primary copy inaccessible. Well, we still have the safe copy in the active vault partition. And notice there is no attack path to the safe copy. There is no way an attacker can gain access to that tape as long as it is in the active vault partition. And let's simulate this attack. If we look at our local Veeam repository, notice that it is the F drive on this host, and we can look at that. We can go into the F drive, and we can see there's some directories in here. There's our backup job, and that's the actual backup image. And this is what the attacker is going to go after. So let's simulate this. I'm going to actually format that disk just to make sure everything is completely destroyed. So let's just indicate we want to format that partition. Okay. And so the data is certainly gone now. Let's take a look at the F drive. And it is empty. Okay. With the primary copy no longer available, our environment looks more like this. All we have is the safe copy in the ActiveVault partition. So we give the library admin a call, and that person moves the tape back to the partition accessible by Veeam. Once the tape is back in the Veeam accessible partition, we simply tell Veeam to repopulate the local repository from the backup. And when the restore is complete, we once again export the safe copy so it will be protected in the ActiveVault partition. Let's take a look at how that's done. The first thing we need to do is have the library admin move that tape back into the Veeam partition. And this is how that works. He takes a look at the media, and in the ActiveVault partition, we have the one tape. So he selects that and just says, remove it from this vault and send it back to the Veeam backup repository. And we can just verify that was successful. As you can see from our partitions, in the ActiveVault partition, there are no tapes. But in the Veeam backup repository, we now have 6 tapes again. Let's look at it from Veeam's perspective. We'll go back and take a look at our tape infrastructure and tell Veeam to go ahead and scan the library. This is just Veeam asking the library for a current inventory. And it only takes a second. And now when we look at our tape media pool, we now have all the tapes back in there. So recovery is very simple. We just tell Veeam to restore from tape. We want to restore backups to their original backup repository. So we just select which backups to restore. We tell it which repository to restore it to, and tell it to run. Okay, that job is done. But let's just verify. If we look at our server here, in the Veeam local repository, we see the backups folder has been recovered. And inside that, there's our job, and here's the original backup image. So at this point, we have completely recovered from that attack. Now that we know our Veeam server has been recovered, let's go ahead and export this tape so it will be safely protected in the ActiveVault partition. So what are the key takeaway points from this demonstration? ActiveVault provides the protection of vaulted tapes without the need to remove media from the library, which results in a faster recovery path. There is no attack path to tapes stored in the ActiveVault partition. ActiveVault is transparent to Veeam, and ActiveVault enables an administrator to recover a backup repository with just a few clicks. For more information on ActiveVault and how you can use it to help protect your data from a ransomware attack, visit our website.